Let us look at nature of standard sequence x to the power of n. Now, this x to the power of n sequence is powers of x, where x is in real numbers and n is in natural numbers. Now, what are the possible values of x? Yes, it is in real numbers, so it can have anything. But we want to look at some specific values and some range of values. So we want to look at x equal to 0 and x not equal to 0. Within that, we want to look at magnitude of x less than 1, which means x is between -1 and 1, excluding 0. Then x equal to plus or minus 1. Magnitude of x is greater than 1. That means it is greater than 1 or less than -1. So let's take it one by one. So when x equal to 0, what happens? We have this sequence. Simplifying it, we get zeros. Now remember the definition of a monotonic sequence. Keep that in mind. Now, since trivially x to the power of n plus 1 is equal to x to the power of n for all n. Basically, what this means is all the terms are equal. So it is monotonically increasing because x to the power of n plus 1 is greater than or equal to x to the power of n for all n. Here, of course, the greater than is not applicable, but equal to is applicable. Similarly, it is also monotonically decreasing because x to the power of n plus 1 is less than or equal to x to the power of n for all n. Again, less than is not applicable, but equal to is. This is a constant sequence with value 0. And its limit as n goes to infinity of x to the power of n is equal to 0 for x equal to 0. So this was pretty straightforward. And because it has a limit, therefore it is convergent. So that was our first case that we have addressed. Now let's look at the second case. Magnitude of x is less than 1. For example, if we take x as 1 by 2, it is less than 1. That is, magnitude is less than 1. So 1 by 2 to the power of 1, 1 by 2 square, 1 by 2 cube, and so on, which gives us 1 by 2, 1 by 4, 1 by 8, and so on. Or, remember, in this case, x can be negative as well. So, if we take x as -2 by 3, then we get this sequence. -2 by 3, 4 by 9, -8 by 27, and so on. So now magnitude of x is less than 1 implies 1 by magnitude of x is greater than 1. If you take the reciprocal, then the inequality changes or reverses. Now let 1 by magnitude of x be equal to, because it is greater than 1 plus some y, where y is greater than 0. And it is fixed, since it depends only on x and not on n, which implies that the magnitude of x to the power of n is equal to 1 by 1 plus y to the power of n. Now let us figure out the lower bound for 1 plus y to the power of n. Now we use the binomial theorem to expand the denominator. So magnitude of x to the power of n is equal to 1 by 1 plus y times n by 1 factorial plus y square times n minus 1 by 2 factorial, and so on, till y to the power of n. All the terms in the binomial expansion are positive. Why? Because here you have n and y. N is natural number, so it can't be negative, and y is greater than 0. So all the terms in this expansion are positive. So which means if we drop the first term and all the terms after the second term, the expansion becomes smaller and hence the RHS becomes greater. So here we are going to take only the second term. What happens? Magnitude of x to the power of n becomes less than or equal to 1 by n times y. All the other terms we drop. Because as of now, it is here equality. It becomes an inequality because we drop all those terms. Now, let epsilon be greater than 0. So now we have to figure out how large must n be so that 1 by n times y is less than epsilon. We get that by solving this inequality. So we get n is greater than 1 by epsilon y. So now we choose m in natural numbers such that m is greater than 1 by epsilon y. Then for all n greater than or equal to m, magnitude of x to the power of n is less than or equal to 1 by n times y, which is less than or equal to 1 by m times y, which is less than epsilon. Just go through this and see whether these inequalities hold or chain of inequalities hold. So now here there is nothing. So we can say magnitude of x to the power of n minus 0 is less than epsilon for all n greater than or equal to m. And this statement, as we have seen previously, implies that the limit as n goes to infinity of x to the power of n is equal to 0. So we have seen when magnitude of x is less than 1, it converges to 0. So we have seen the second case as well. Now let's look at the next case, that is x is equal to plus 1 or simply x equal to 1. So that means x to the power of n sequence is equal to 1 to the power of 1, 1 square, 1 cube, 1 to the power of 4 and so on. Simplifying it, we get just ones. Just like in case of 0, trivially, x to the power of n plus 1 is equal to x to the power of n for all n. So it is monotonically increasing because x to the power of n plus 1 is greater than or equal to x to the power of n for all n. Again, here also greater than is not applicable, but equal to is applicable. It is also monotonically decreasing because x to the power of n plus 1 is less than or equal to x to the power of n for all n. Again, only equal to is applicable here. So, just like for x equal to 0, this is also a constant sequence, but with value 1. And limit as n goes to infinity of x to the power of n equal to 1 for x equal to 1. And therefore, it is convergent. We have seen this case as well. Now, let's look at for the next case, minus 1. So, when x equal to minus 1, we get this sequence. Simplifying it, we get minus 1, 1, minus 1, 1 and so on. So we have alternating signs. Now limit as n goes to infinity of minus 1 to the power of 2n minus 1 is equal to minus 1. So 2n minus 1 is nothing but odd index. So odd index subsequence converges to minus 1. Limit as n goes to infinity of minus 1 to the power of 2n is equal to 1. That is even index subsequence converges to 1. So here, just remember that these powers, I am treating it as index as well. So they are powers as well, and I'm using them as indices also. So which implies minus 1 to the power of n oscillates between minus 1 and 1 discretely. Since a sequence can have only one limit, remember uniqueness of limit. Limit as n goes to infinity of minus 1 to the power of n does not exist. Now, magnitude of x is greater than 1. That means it is x is greater than 1 or x is less than minus 1. So let's look at x is greater than 1 first. So for example, let's say x equal to 2. Then we would have 2 to the power of n equal to 2 to the power of 1, 2 to the power of 2, 2 to the power of 3 and so on. Let y is equal to 1 by x. Since x is greater than 1, since x is greater than 1 in the denominator, that means y is less than 1. And since x is also greater than 1, that means y is between 0 and 1. And if we take the power n, it becomes y to the power of n is equal to 1 by x to the power of n. So limit as n goes to infinity of y to the power of n is equal to 0. Since magnitude of y is less than 1. Now this we have already seen this case. Magnitude of x is less than 1. If that is the case, then the limit is 0. The only thing is, instead of x, we have y. So the reciprocal of y to the power of n diverges to plus infinity. Because limit of y to the power of n is equal to 0, that means its reciprocal will diverge to plus infinity. Since y to the power of n goes to 0 while remaining positive, that implies limit as n goes to infinity of x to the power of n is equal to plus infinity. Since x to the power of n equal to 1 by y to the power of n. That takes care of this case. Now, we have to look at the last case. That is, x is less than minus 1. So we have x is less than minus 1. Again, for example, if x equal to minus 2, we have minus 2 to the power of n is equal to minus 2 to the power of 1, minus 2 square, minus 2 cube, and so on, which basically gives us minus 2, 4, minus 8, and so on. The subsequence x to the power of 2n minus 1 consists of negative terms whose absolute values increase without bound. And the subsequence x to the power of 2n consists of positive terms whose absolute values increase without bound. Thus, the sequence x to the power of n oscillates between negative and positive terms while its magnitude grows without bound. Which means what? Which means the limit does not exist for x less than minus 1. So that was our last case. Now let's summarize the whole thing. We have nature of x to the power of n. When x equal to 0, a constant sequence with limit 0. Magnitude of x is less than 1, converges to 0. X equal to minus 1, oscillation between plus or minus 1 and hence diverges. X is equal to 1, a constant sequence with limit 1. X is greater than 1, diverges to plus infinity. X is less than minus 1 implies oscillation with unbounded magnitude and hence diverges. That was nature of standard sequence x to the power of n. If you found this session helpful, please do like, share and subscribe. Comment suggestions are always welcome. Thanks for watching. See you in the next session. That's it for now.